This is lecture number 4. The concept is the new nickel and industrial applications. And how the new nickel based alloys will be helpful for industrial applications, and how the main current research will be going on is new nickel. These are the concepts involved in the metals alloys. In course name is advanced materials. Presented by Dr. Rajani Sheikh, Professor of Ramchandra College of Engineering, and developed by Jawaharlal Nehru Technology University, Kakinada. And coming to these main research activities within new nickel-based intermetallic alloys having fundamentals of the solidification both at planar, cellular, and dendritic solid liquid phases. You can observe the structures, how these structures will be helpful, and what are the different conditions applying is very, very important. And how it will be helpful and what is the need of doing is very, very important. And these all conditions will be applied when we are discussing for maintaining the surfaces or improving the strength, and how the essential for the different applications. In these new nickel-based alloys, having the main research going on for these different applications like aircraft or aerospace or any other industries. The concept of these conditions having the microstructures characterization of the nickel or aluminum chromium based alloys. In this heat treatment of nickel aluminum chromium based alloys having the maximum room and high temperature mechanical properties of nickel aluminum chromium based alloys. This shows the intermetallic alloys and how it will be helpful and what is the need of doing is very, very important. You can observe these are the microstructures, how when we are heating these nickel alloys and what are the different structures and different elements involved in this one. Microstructures takes the main importance for the pure metal and base metal, how it will be changes when we are heating to get the manufacturing of unique products. These microstructures will be done. First structure is in 100 micrometers. You can observe the structures, how it will be applicable for this. This is the dendritic structure of the multi-phases involved in the nickel 21.9 aluminum and 8.1 chromium and 4.2 tantalum and 0.9 molybdenum and 0.3% of zirconium. These are the intermetallic alloys. These all mixing of the structures shows the dendritic structures of the multi-phase alloys. And coming to another structure is having the 2 micrometers. In these 2 micrometers having the microstructures shows the SEM microgram, showing coexisting regions of the directional solidifications. These are the dendritic region. You can observe these structures having the I is interdendritic region, and P shows the chromium based particles, and these are the gamma, alpha. Alpha is the chromium, gamma. Different. These are the phases involved in these regions and how it will be having the. You can observe this picture shows the importance and improving of the strength and applicability of many industries. This main importance shows the conditions depending upon different properties. And properties are for these new nickel-based alloys and how it will be applicable and how it will be useful for different industrial applications. The property shows a resistance to high temperature oxidation, nitridation, and carbonization, and having the fatigue resistance having superior to that of nickel-based super alloys. It's having high yield strength in a large temperature range, good tensile and compressive yield strength at 60 to 1100 degrees centigrade, and having the inferior mechanical properties comparing to those of recent simple crystalline nickel-based super alloys. And coming to industrial applications having transfer rolls, heating or treating trays, centrifugally, cast tubes, These all are based on the getting the new research on the nickel based alloys. How the concept involved for different applications is very, very important. You have to understand how it will be applicable for industrial manufacturing using for the current trends and current technologies, and how it will be applicable, how these applications will be helpful for the society in national level and international level for manufacturing for different conditions. And it is the having rails for walking beam furnaces and die blocks, nuts and bolts, and corrosion resistance having the tool bits and single crystal turbine blades. These are the conditions satisfying for this many other industrial applications. These nickel-based superalloys, this is the grade shows the coding of during the early stages of primary, keep showing and how the dislocation, you can observe how 500 nanometer structure takes a major role like droplets or different structure generated and how this ribbon passing through the both recipients and matrix will be applied. And what are the different mechanical properties and microstructures used for the turbine based or entry level temperatures having from 800 degrees centigrade to 1600 degrees centigrade, how the material development in all turbine components, how this critical achievement will be used for different engine conditions, and how these engine designers are looking for maximum temperature is 81 degrees centigrade to increase the engine efficiency and to reduce the environmental impact. For any research or for any condition satisfying for any purposes, having the environmental impact is very, very important. And we have to focus on understanding of the fundamental mechanism and determining the mechanical properties of turbine materials and use it to produce tools and strategies for material development and life prediction. And how these alloy development are fourth generation single crystal alloy takes, how these nickel based single crystal superalloys can be strengthened by addition of the tungsten and rhenium by doing so while maintaining reasonable density, stability, and environmental resistance requires careful optimization of the composition. These are the development of the nickel-based alloy for fourth generation alloy. This is the concept. You can understand how these super alloys or nickel-based superalloys and nickel alloys will be helpful and how it will be stability and it will not disturb the environmental conditions for optimal levels. You can observe the two pictures or two images. First image shows the graphics of these diagrams of the graph. Keep strength at 1880 degrees Fahrenheit. It is maximum 0 to minimum 0 to maximum 350 degrees centigrade. You have a nickel aluminum and nickel aluminum titanium and nickel aluminum base. And this is nickel based superalloys having the free strength comparison of the bind rate. It is the alloyed nickel aluminum single crystals and having the first generation of the single crystal nickel based superalloys made at 1026 degrees centigrade and strain rate and having the metal structure of creep resistance, nickel aluminum and single crystal alloy, having the 1 micrometer. And coming to mnemonics, what is the mnemonics component and how it will be helpful and what are the conditions of this? Mnemonics is the key component of the microstructure of displays nickel, iron or aluminum. It is the modern superalloy might be 60 to 85%. Nickel is effective as flow holding together. It shows the structures of the 0.2 micrometers. This is the images and structures of the picture shows the yield stress increases with increase in temperature up to about 700 degrees. You can observe these x-axis having the temperature, how it will decrease 200, 400, 600, 800, 1000 to 1200 degrees centigrade. This is temperature and the yield stress parallelly with respect to temperature, how the yield stress will be increased in megapascals is 0 to 100, 200, 300, 400, 500 to 600 degrees. This is the maximum percentage. When we are shown 200 yield stress megapascals having 100% percentage and 80% is for 300 Hg megapascals and 60% for 400 megapascals of each phase and 500 Hg megapascals, 40%, 600 megapascals to 20%. When we are increasing, the automatically percentage decreases. How the varies with respect to temperature is very, very important. This is the temperature shows the maximum 0 degrees centigrade to 0 degrees centigrade temperature varies. How different strengths useful versus elongation. For any material and for any product, for any metal or very it is superalloys or nickel based alloys, the melting temperature and maximum temperature is very important. In this graph shows the elongation with respect to yield strength and the tensile strength. Elongation will be maximum with respect to the 2000 degrees centigrade and having the yield strength is 0.2% of the offset. And tensile strength will be maximum increases with respect to elongation percentage. How the temperature elongation will be multiple conditions satisfying is very, very important. This shows the clear picture and clear images of the multi-structures, how it will be stable in conditions, and how finally divided with respect to spread distribution, how it will be tend or driving the force is lowering of potential energy, and how the nearly exactly lattice fractured with the nickel matrix interfacial energy is nearly zero. You can observe how the nickel based in pink color and how this gamma phase having the light conditions in these are the nickel and aluminum conditions satisfying. How this microstructure will be stable to improve the energy in the maximum conditions. How the energy will be improved with respect to the stable conditions. These are the main concepts involved in this new nickel alloys for the helpful for the industrial applications.